spy masters have written their memoirs now. And some of you may know Arnold Kramish. Any of you met him? Well, he was in on the most secret things that went on, like counterintelligence. And Arnold Kramish said to me a couple of years ago, you know, he said, in my mind, there is a 50% chance that Louis was a spy, which kind of fits in with your characterization of him as being used to danger. He fought in the Spanish Civil War. Yeah. Well, we'll never know. But Arnold Kramish, who was the primary spy catcher, and he knew about the Hall affair, this young guy who came to Oak Ridge and was at Los Alamos, and he spilled the beans at a level that was matched only by Fuchs.
There's another interesting point, and that is that Canada, his native country, regards him as a hero.
That's
and
right.
They've dedicated a park in his name.
Yeah. Well, I think that's great because these things people say are completely unprovable one way or the other.
Well, I guess that accident changed the philosophy of safety a whole lot. I didn't join the experimental group until '55 when we were behind 5 feet of concrete, and we never did any hand stacking or anything else to
Something I'd like to ask you and Dixon. There was, before the Slotin incident, the Dalian incident. You know, Dalian was the guy who did a critical experiment all by himself at night, and he killed himself. And I was just wondering, what was Los Alamos's response to that incident?
I wasn't involved that early.
My interpretation of it was that it was his fault for going in there and doing that all by himself, without authorization. And so it was a fluke. And therefore, they didn't need to do anything special in the way of protection. Normally, you would be very, very careful. But he went in there and was careless. So you could ignore that incident. Now, that was a bad mistake because Slotin's work was exactly the same problem. And 1 year, almost to the day, after Dalian's death. So, Los Alamos lost the ball on that one, I think.
The Douglas incident taught what small fraction of hand stacking, quote unquote, was done after his death. But he taught us this basic principle. If one is assembling fissionable material by hand, you don't come in like this with a piece. You come up like this and across with a piece. Because the Douglas accident was lack of his holding on to a chunk of whatever he was handing out, whether it was beryllium or plutonium. And he came in above, and I guess he was under tension, maybe perspiration had something to do with it. At any rate, he dropped the piece from here onto the thus far completed assembly. So that at least taught us, if you come up and you come across like this, and add the next increment, That was one lesson we learned from that.
Well, were you in the criticality business at that time, Dixon?
No. I came to Oak Ridge in March of 1946 after a terrible introduction to the Manhattan Project at Columbia University. And so that was my first contact with anything nuclear in the Manhattan Project. And I was always very proud of it. Still am. Dahlgren was 45. When was Dahlgren?
There's a picture of it here.
About a year before
It was
Sloat.
1 year before. 1 year, what it says.
21 August 1945.
Yeah.
Plutonium core reflected with tungsten carbide. And the Slotin accident was on the 21st of May, which was, what,
Yeah.
2 or 3 weeks after
Thank
you
you,
fellows
yeah.
had left there. This was the first accident, Dalian, and this was Slotin, of course, a reenactment with the
Yeah.
screwdriver. And this is in a document that, Alvin, you have a copy of this?
No, I've never seen that.
Yeah, this is your.
Oh, you can get another copy of it? Thank you very much.
Well, that's a nice compilation of accidents both in this country and in the former Soviet Union.
Oh, good.
Dr. Callahan explains the need for data on potential criticality of fluorine compounds by the K-25 gaseous diffusion plant. Y-12 also needed information for its uranium chemical processing system. Critical experiments at Los Alamos and Oak Ridge involved use of cubes of uranium and of plastic. Personnel from the nuclear aircraft project of the 1950s were assigned to the group.
The discussion seems to be flowing in the direction that we had planned, basically talking about the early days of setting up a program here. Dixon, why was the program set up at K-25? What was the need in setting up critical experiments?
Well, let's remember you're talking about high-level decisions by high-level people, and I was just a peon. At that time, the top enrichment in gaseous diffusion of the uranium isotopes was 30%. And I don't want to infringe on other parts of this program, but I will, of necessity, say the following. There were probably two reasons why the cap at 30% was put on K-25. One was K-25 was such a tremendously large project. It was running behind. So Y-12 got into the really high enrichment business before K-25 did. The other was ignorance of what the critical conditions for UF6 would be. So we did, Cliff Beck, Ray, myself, did a series of experiments at Los Alamos to explore possibilities of setting up a chain reaction in the Cascade. The gas was never a concern, of course, although years later, I think John Morfitt at Idaho made UF6 gas critical with a beryllium reflector, and I don't know what else. He never did publish it. But there were two actions that could have caused a solid accumulation. UF6 is sort of a nasty stuff. It's hygroscopic. It jumps on the water in the atmosphere and forms a cloud of UO2, F2, uranium uranyl fluoride, solid, which could accumulate, perhaps. And secondly, at room temperature, UF6 is a solid, so if there were, secondly, UF6 is quite corrosive, and it can attack metal surfaces to give UF4, another solid. So there were potentials of accumulations by moisture leakage or by chemical reaction of a solid uranium compound in the cascade. So every effort was made in these experiments, and I apologize, Ray, but I kind of led into this, to duplicate, from a nuclear standpoint, solid UF6. A material that at least looks like UF6 to a neutron. Whether it looks like UF6 to you or to me is immaterial. So, as we will learn shortly, we had a pretty good simulation of UF6 in the Los Alamos criticals. Long way from critical. We only had 50 kilograms of U-235. So in answer to your question, I think one is just to put people at ease that it's highly unlikely that anywhere near critical quantities of uranium could be accumulated in a chain reacting environment, if you please. And that's no doubt economically important, because there's a story floating along, and when K-25 then, after that Pyrita experiments, the Oak Ridge Cruise experience at Los Alamos, Y-12 was reduced by some 20,000 employees. I can't verify that, that's what I was told at the time. So there was economic concerns once there was assurance that there were no severe safety concerns from one region or another. So I presume that those are the things that went into the decision to do these early experiments. It was a wonderful experience.
Right. Pardon me, Dixon. The other topic I think might be appropriate to discuss while Alvin's still with us is the construction of building 9213 and the basically the transition of the program from K-25 into the laboratory in the, I understand, 1949, 1950 time frame. Do we have enough time for that, Bruce? Mm-hmm. We do. You want to show some of those pictures?
It would take too long to bring that down, but I can certainly try.
Okay. I had a privilege several weeks ago of meeting with Dixon, and I was always curious about how the program started at K-25 and then transitioned into the laboratory. And very interesting anecdotal experience in how the facility was acquired. It was multiply funded and multiple programmed. Dixon, would you like to lead off with that, with your interest in moving out of K-25 and into 9213? And well, we have some pictures and some diagrams showing the facility.
That'd be a while.
Well, a word about the building. We did all we could with the time and facilities at our disposal at Los Alamos. We just showed that the potential for criticality was solid UF6, no hydrogen, was possibility was pretty remote. As I said earlier, the cap on enrichment at K-25 at that time was about 30%. So somebody said, well, let's see what the critical quantities are of 30% enrichment. And so we got, again, 50 kilograms of U-235, which now is about 3 times the uranium inventory that we had at Los Alamos, and made more blocks and did more stacking, remotely operated. There was, in those days in Oak Ridge, a 4th production facility, not highly touted, not very effective. That was thermal diffusion in the so-called S50 area, which was centered around the K-25 powerhouse. And it had operated. We were, there was made available to us a small building, which I characterized by saying if we wished to cable from this room to this room without any compunction, we knocked a hole in the wall, ran it through. We opened some cupboard doors, found a nice piles, green sold. But anyway, it was space, and we took it and set up in 2 rooms with a nominal shielding in between, comprised, among other things, of 2 fish aquaria, and did these 30% experiments there. Then came the chemical engineers. How big can I make this extraction column? That led us to solutions. And we used the same facility. Got UO2F2 aqueous solution of 9212 and Y12. And literally we just outgrew our assignment. So it was prudent to treat ourselves better. In the meantime, also in that area in Oak Ridge, Fairchild Camera had a contract for aircraft propulsion. And they had a staff, and they had some office space. They never got any uranium. They never had a laboratory. But on loan to us came some very excellent help. Fred Pressey, Mooney Ham, Daniel Weinberg, the head man, let's see, I'll think of it directly, no matter.
Miles Leverett?
No, well, it's not important, I mean, it's only other circumstances. And then they worked with us and just became effectively a part of our team. But we got, I think, we got some money from the Air Force maybe to put into a design of a building for that purpose, not a makeshift affair. At that same time, K-25 was expanding at a terrific rate. 29, 31, 33 were in design. And the architect engineer was Giffels and Valet out of Detroit. Superintendent of K-25 at that time was Bill Humes. He's a let's get it done sort of person. So he says, well, let's get Giffords Valet to design this little building. We can bury the cost someplace. So we did. Made a big cell, 30 by 30 by 30 roughly. 5 feet of concrete, water-filled windows, 5 feet. And with all the things that we could think we needed, it was a wonderful design. And about the time it got on paper, I believe this gentleman said, let's do aircraft experiments. Why don't you just fold your blueprint over and build a second cell on the east? Well, everybody was happy with that but Giffords and Valet. They said, you just can't fold it over. So they started in and designed the facility, I guess as it stands today, physically. And long about that time, Fairchild gave away to General Electric as the contractor for the aircraft propulsion, nuclear propulsion project. Miles Leverett was in on it and worked towards nuclear adjunct to the jet engine plant in Evendale outside of Cincinnati. And he stole John Morford from us. And they ultimately, I guess, got things nuclear before they moved it to Idaho. I lost my contact. But we built up a staff. Someplace in your agenda you talk about training, and I will settle that one, I think, real easily and say we just did on-the-job training. We just said, okay, this is the way we'll do it, and we did it very cautiously.
In this topic, Dixon Callahan reviews the use in 1946 of the F-05 laboratory in the thermal diffusion complex at K-25. Critical experiments are performed by remote control of a split table and of a solution transfer system. Thick concrete shields separated assemblies and the control room. The program was transferred in 1950 to ORNL, and Building 9213 was made available. The new facility provided ample space for experiments.
So that's sort of the history, except for this, which I really had planned to say later, but I'll say it now. Bill Humes and I went down to the headquarters at Oak Ridge, talked to Sam Sapiri, a wonderful person. Sam says, we can't get anybody for reconstruction. We can all get all kinds of money for refurbishing or rebuilding. And he reached over and pulled out a stack of blueprints and said, here's a possibility. Parenthetic, and on the side, there's something I've got to say. I'm sure you have observed that in the Y-12 complex, where this structure to which he referred was located, the buildings were numbered 9212, 9211, 9213. Just like K stood for Kellex, but 25 was the code word for it was uranium. I've always laughed to myself about the extremes of security. But anyway.
What is the photo, what is the drawing number of 9213? I was looking for the drawing number of 9213.
I don't know. I haven't got it.
I have it. It's
Well, anyway.
38049.
out in the woods, literally,
Nice
the
picture.
back corner of Y12 area, was a building which had been used, I'm told with great certainty, as a stop-off place for enriched uranium. Y12 was grinding out 92, 94% UF4, packaging it for shipment to Los Alamos.